like to introduce Harsha Kumar. He is technical advisor and manager at TSN Solar for Fronius Canada. And today we're going to be talking about the Gen24, which was finally rolled out in 2024. Brand new product from Fronius. I'm really excited about it. I'm going to be talking a little bit about retrofits as well, I believe, right, Harsha?
That's correct.
Perfect. So with that being said, quick rules. If you have questions, feel free to put those into the chat function. We'll be trying to address those as they come, but then also towards the end, we will have some time to ask some of those questions to Harsha. So we'll address them in the chat as well, but then also ask Harsha at the end when he has time to answer those. Besides that, if you're not speaking, mute yourself just so we don't have any background noise. And yeah, so Harsha, floor is yours.
Thank you, Danny. Hello, everybody. Good day, and thank you for attending this presentation today. We're here to basically introduce our next hybrid inverter, which we call the Gen24. In addition, we will also be addressing the concept of retrofits, which basically is replacing only the inverter on an already existing array for various reasons, right? So without much delay, let's get into it. Okay, so this is the agenda I've got for you today. We'll be talking a little bit about Fronius and then kind of jumping into the overview and the other different topics about the inverter itself and how we get to use it. And at the end, we'll finish it up with the retrofits. Now, if you do have questions, please feel free to interrupt me. There's no need to hold it till the end. Okay, so Fronius is and was and still is a family-owned business. It was started by Gunther Fronius in Pettenbach in 1945. And Gunther Fronius is the person you can see there who's leaning up against the car. And it started off as a manufacturer, or rather, to manufacture battery chargers. And so these were exclusively automotive battery chargers. So you can see one there, one of the earlier models. And he basically started it in his garage. So like I mentioned, it was a family-owned business, and it still is, and it is currently in the third generation of family ownership. And we are not a publicly traded company; it's entirely private. And since then, we've kind of grown because, like I mentioned, we started off as a battery charging or a maker of battery chargers. And then the technology was basically taking AC power, which comes from the utility or from hydro, converting it into DC and using that to charge your battery. Now, that was the oldest business unit, which we call perfect charging. Then we had the next breakthrough, which was basically the welding technology, which again is basically conversion of energy from AC to DC and vice versa as well. The youngest of our business units is solar energy, which started in '92. And one common thread between all of these different products that we are talking about and which we make is energy conversion and the hardware to go with energy conversion, which is our area of expertise. We are basically a manufacturer of power electronics hardware. So it is electronics. It deals with much higher levels of power than typical consumer electronics does. Now, this is kind of going back there. So we are a family-owned business, and it is an Austrian company. Our products are made in Austria, not anywhere else. Okay, the subsidiary itself is Canadian, though. So although the headquarters is in Austria, we have presence in various different countries, and each of those countries that we are present in have local subsidiaries, which are all locally owned. So for example, we are the Canadian subsidiary of Fronius International. We are Canadian, we are diversified. What I mean by that is we are present in all the three different business units that I just tell you about. We are invested and we are bankable. We've been here for a very long time. And also, since we are invested in three different business areas, we kind of leverage off of them because not all businesses are always at, what should I say, their peaks, if you will. So we use that, and that is actually how we work in terms of, being bankable as well. Okay. Now, if you have used Fronius in the past, which I suspect a lot of you have, you would have been exposed to our older models of inverters. So the oldest one which we have in the market currently, but we don't make, it's been phased out, is the IG+. So that is older technology. It is transformer-based technology and is basically meant to work with grounded PV arrays. Okay, that's the oldest one. Then the technology changed and we got into transformer-less technology, which is where we got into making the primos and the simos. But those again were older inverters because they've been now on the market for more than 10 years and they've come to the end of their life, if you will. They're still available. We still make them. We still have production lines in Austria, but they, what should I say? The codes and requirements in terms of what the authority having jurisdiction, which is basically hydro companies, that evolves with time. And because that evolves with time, that didn't mean that we can always go back and re-engineer a product. So because sometimes it might not just be worth the effort, and it might not even be cost effective as well, which is why in those situations, what we do is we will continue making those products for sale in areas which do not per se need those new codes and stipulations. But if you do need need to comply with the new code, for example, then we would rather sell you a newer model of inverter. For example, in this case, it would be the Gen24. Now, one common requirement, which is, what should I say, getting increasingly prevalent in the market, is the requirement for UL 1741 SB. Now, the existing primos and the simos, which are still being made and sold, they do not comply with UL 1741 SB, despite meeting a lot of those requirements, but not entirely. Okay, so but if you did need to, what should I say, comply with UL 1741 SB, then this model of inverter, which is the Gen24 Primo single phase alone, does meet that requirement. Okay, so here's a little bit about that. It is a single phase inverter alone. So although it does say 208, what that implies is that it could be used on one leg of a three-phase 208 system, or you could use it 240 across lines. Okay, now it comes in different capacities, hardware classes as we call them. So you can have 3.8 kilowatts, 5 kilowatts, 6 kilowatts. These are all AC output capacities. Those come as one physical frame size. And then there's a change because the next physical frame size is for the 7.7 kilowatts and the 10 kilowatt units. Now, irrespective of what power capacity the inverter is, all these inverters are capable of working with two MPPTs, which could be used even as a single MPPT device, should you want. And in addition, it is a hybrid inverter that is capable of working with the battery. We'll get into that a little bit later on. And whatever features you might have been used to when it came to the IG Plus or the primos and the simos, those benefits and features have stayed the same. So what I mean by that is it is still NEMA 4X, which is IP66, okay, not waterproof, but splashed, what should I say? Splashing waterproof or rainproof, if you will, which means you could use it outside, okay, but just make sure you don't have it submerged, that's all. In addition to that, the operating temperature range, we maintain the same. It's minus 40 C to plus 60 C. If the temperature were to be below minus 40 C, the inverter will basically stop functioning in order to protect itself. On the high side, it can work up to an ambient of plus 60 C. If your ambient is higher than plus 60 C, then the fans will kick in. But if the fans aren't able to basically throttle it, but typically you tend not to have ambient temperatures of plus 60 C unless you're inside of unventilated enclosed space. So in which case, too, it will basically start derating, basically throttling how much power it puts out. Okay, now in terms of PV planning facility, flexibility, the start voltage is 80 volts, okay? But that didn't mean you should be working an inverter at that low voltage, because you have to remember that the inverter is an electronic device and all electronic devices are current limited. So what I mean by that is the amount of current that the inverter can handle is fixed. There's a maximum to it. But from the calculation for power, we know power is voltage times current. So if I want to extract the same amount of power at that low voltage, the corresponding increase in current is not actually possible, which is where the current limitation comes in. So what I mean by that is try not to work your strings at too low a voltage because your current will saturate. Now on the
Quick question here. When you say 3 modules, what type of mod? Because obviously it's different if you're using a 54 cell panel versus a 72 cell panel. What type of panel were you looking at with the 3 modules per string?
Not necessarily what kind of panel. It was more about basically saying that you can start that low. The reason when I say that is 3 modules per string didn't per se mean the open circuit voltage that we were referring to. We were basically kind of referring to, once your panels start getting hot in summer, even if I had 3 panels in series and the open circuit voltage for each of those was, let's say, 42 volts, it should be approximately 120 volts. But once you start drawing power from them, the MPP voltage is usually about 70 to 80% of that open circuit voltage, which kind of comes down to 80 volts. That's where I was getting to. Not so much how many cells we have in each module.
Also, a quick question while I got you. Tony asked about if there's any plans for a third MPPT in the future.
Our next version on a three-phase, yes, that's actually going to be either 3 or 4 MPPTs. But currently for this version, it's going to stay at 2 MPPTs.
Only on three-phase, not on single-phase?
The single phase, I know that they're working on a higher class, like power class, because this is currently limited only to 10K. So I know that, like, I'll put it this way, don't quote me on it, but I know that they're working on it. I'll put it that way.
Thanks.
Okay, now one big difference here compared to the old primos and the SIMOs is that the old primos, despite being single phase, even the 3.8 kilowatt inverter could work up to 1,000 volts DC. That is not the case anymore here. Okay, so these are all exclusively 600 volt DC inverters, and they were meant as such for residential use. That doesn't per se prevent you from using them on commercial sites if you do need to, or even ground mounts, because we've already seen a few people use them on both, and there's been pretty much no difference there. But this also does stand you a little bit of an advantage in a different way. I'll come up to that when we get to the retrofit side of it. But for now, please keep this in mind always, that when you do design this, that the maximum input voltage is 600 volts DC. So your open circuit voltage, even at the lowest temperature you would expect to see at the site, will need to stay under this if you intend not to damage the inverter. Okay, now the MPP, what we saw there was basically the operating range, if you will. But in outside of that, you also have to keep in mind that the string voltage is more, what should I say, geared to be worked at for the MPP voltage rather than the open circuit voltage. So which is why the MPPT voltage range is also just as important. But like I mentioned earlier, you always want to design the strings that you intend to work with to be higher than lower, simply because at higher voltages, the amount of current required for the same amount of power is lower. And if you can keep the current lower, typically your losses tend to be lower, and it makes for more efficient operation. And you'll also save on the cabling cost as well. Okay, now, like I mentioned earlier, all inverters across all capacities come with 2 MPPTs. The smaller frame size, which is the 3.8 kilowatt, the 5 kilowatt, and the 6 kilowatt, across the 2 MPPTs are not symmetrical. MPPT1 is a third larger than MPPT2 is. Okay, so which means that 66% of the inverter's capacity power-wise is allocated to MPPT1 for the smaller frame sizes, and a third is for MPPT2. So the usable current on MPPTs 1 and 2 for the smaller power classes are 22 amperes and 12 amperes. That didn't mean that you need to limit yourself to that, because the short circuit current is much higher, the short circuit capacity, that is. So for the MPPT1 on the smaller frame sizes, the usable current is 22 amperes, but the short circuit current capacity is 36 amperes. Okay, so which means that now you can even use the higher powered modules, which tend to have much greater short circuit currents than the earlier ones, when the Primo or the SIMO were launched. Now, similarly, on MPPT2 of the smaller power classes, the usable current is 12 amperes and the short circuit capacity is 19 amperes. For the larger power classes, the power capacity is equally shared across both MPPTs. So it is not, 2/3 and 1/3 like the smaller power classes. It is 50-50 on the bigger power classes. So the usable current on both MPPTs for the bigger power classes are 22 amperes each, and the short circuit current capacity for MPP Tracker 1 is 41.25 amperes, and for MPP Tracker 2 is 36 amperes. So this again will enable you to be able to use the higher power PV modules, including the bifacials, which are now currently on the market. Okay. In addition to that, we have one battery input for 22 amperes, and that should also give you an idea that these are only able to work with high voltage batteries. Okay, so that is the reason that the current there is that low. In addition to this, we also allow for oversizing, and the maximum permissible oversizing without voiding the warranty is 150%. What I mean by oversizing is the size of the PV array in watts or kilowatts connected to a particular size of inverter, and the ratio between the inverter's AC output versus the DC input connected to said inverter. So for example, if I have a 10 kilowatt inverter that I'm thinking about, the maximum permissible DC array size that can be connected to this inverter, making sure that the current and voltage are still within limits, is 1.5 times the inverter's rated AC capacity, which means for a 10 kilowatt inverter, I can connect a 15 kilowatt PV array. Okay, now There are situations where you might want to go over that. If you have such requirements, please contact us, because sometimes what we do is we put in what we call an oversize or a deviation request. And if the R&D team thinks that it is safe for our climatic conditions, they will come back and give you a little certificate saying that this particular design, despite going over 150%, is allowed without voiding the warranty. Okay, now that is as far as the features go. Now, in addition to that, you also have to make sure that the strings of PV modules that you connect to an inverter is actually something that the inverter can work with without causing any trouble or damage to the inverter. How do we know this? Typically, people do hand calculations. Now, hand calculations are good when it comes to calculating the PV array behavior, okay, because your hand calculations will tell you what the open circuit voltage at a particular temperature is on both the high and the low sides. You can calculate what your short circuit currents are, what your MPP currents are, your MPP voltages, etc. But what you cannot do with your hand calculations is take into account device limitations. Okay, you have to remember that the PV array is one part of it, but that has to kind of, what should I say, tango, if you will, with the inverter. And the inverter, depending on who makes the inverter, they come with their own device limitations, which aren't always as easily understood. So despite you having performed your hand calculations and come up with a string design, we always suggest and recommend that you run those numbers through this tool. This is just a web page and it's free. You can choose to sign in if you want to. There's no charge if you want to create an account and sign in. You can also not sign in and use it as a guest. But what you always want to do is to plug whatever numbers you have in mind through this tool while making sure that the numbers you're putting in here are relevant to us in Canada, and then making the right choice. And then the table that you see there, where you can see, the numbers in bold, starting with 14, 15, 16, 17, 18, etc. The table beneath there is the suggested configurations of string designs, which are safe for working with this model of inverter. Okay, so this is where the tool has built, what should I say? It's got the device limitations worked into it. So you don't have to go through the hassle of understanding those device limitations. Now, you would have done your own calculations, based on Excel, etc., whatever. Just plug those numbers in here. And so once you see that whatever you had in mind is something that is suggested by the tool as well, you can be absolutely sure that you aren't going to be, what should I say, destroying the device with this particular design. And at the same time, it is also likely that you will get the expected output as well. Now, one caveat when you use this tool is you have to remember that you are not plugging in the angle, the pitch that is, or the azimuth into the tool. Okay, if you have any shading issues, if you have any array, what should I say, spacing issues, etc., all of that cannot be worked into this. So those are things that you would have to keep in mind as an installer when making sense of what design you'd like to go with after having verified it with this tool.
Quick question. A couple of questions. David asked about the oversizing.
Yeah.
And if this includes bifacial modules, so should they put in the expected bifacial gains into this 150%, or is that not required?
It is required. So for example, here you can look at this example on the tool that you see here. There's this little field called inverter ratio. The default on it, if you were to just load the tool without having plugged in anything, is 80 and 120. I've changed it to 150. Okay, so all the changes that I've made here, like for example, I've set the temperature to -40. It's highlighted in yellow. You can see that. And on the high side, the inverter ratio is set to 150%, and the bifacial gain is set to 0. Okay. Now, if I include the bifacial gain based on whatever percent you expect, depending on what your albedo is and how they prepared the surface behind the PV array, then you can plug those numbers in there, and you will see that that is taken into account within the 150%.
So for the warranty, I think this is what is being asked about. So let's say you oversize a system to 150%.
Yeah.
Using so you, let's just for argument's sake, you put I have a 5 kilowatt inverter and put 7.5 kilowatts of panels.
Yeah.
They're bifacial panels. Do you void your warranty at that point?
If you've got these calculations here, and you can show us that your calculations were, one of the options from this tool, then it won't.
But who's to say what the bifacial gain is?
That depends on what you plugged in there. So
no,
because
sure, but I mean, let's say you're saying no. Let's say you're not saying, you're saying you don't have any bifacial gains.
Yeah. I'll put it this way. once you plug it in here and you can see the operation of the inverter online, you'll actually get to kind of predict what your bifacial gain is like. But typically your bifacial gain is more of what should I say, a gray zone, because it's very rare for us to void warranties based on bifacial gains, because it's not something that you can either prove or deny.
What exactly? So that's my question.
Mhm.
So let's say you put it on a ground mount,
Yeah.
right?
Mhm.
Which you probably would have some bifacial gains, but
Correct.
who's to say what those exactly are? And you put in 0, do you void your warranty at that point, or will Fronius
No,
honor the warranty?
we will honor the warranty. See, typically, if
Okay.
you've run your design through this tool, this is actually more looking towards your voltage limitations rather than current, because your voltage actually is more, what should I say, is actually what destroys the device. Your current ages it, that's all.
Yeah.
In the sense, it runs your device harder and harder. So typically, that's not how your device fails. It's more because of your voltage,
Correct.
going beyond
But
600.
just to make it very clear that generally that's not what, like David, you can still oversize by 150 without the bifacial gains, but we would recommend that you use it for string sizing, that
Correct.
you calculate in some bifacial gains, because your voltage may get too high that way, and then you may damage the unit there. So you should always make sure when doing string sizing that you calculate in some bifacial gains. Is that correct?
Exactly. That is correct. And also your bifacial gain contribution, like I mentioned, is, you typically tend not to void the warranty on the inverter because of the bifacial gain contribution. If there is damage, it's more due to the bifacial contribution to the short circuit, because your short circuit current goes up on a bifacial gain too. So it's those limits like voltage and the short circuit current that is more influenced by your bifacial gain when it comes to voiding warranties, if it came to that. Okay, now, yeah,
perfect.
go ahead.
Let's continue. We'll get to more questions later.
So if you don't have any questions on the tool itself, I'm going to go to the next one. Okay, so now if you have worked with the Fronius inverters in the past, you would have seen like how, like if you worked with the IG Plus, let's assume you had to exchange the inverter for whatever reason. Maybe it was a warranty claim, or maybe you got struck by lightning, God forbid, things like that. So now in those situations, you would have seen that initially if you had to switch out an IG Plus, you would literally have to undo all of the connections and redo all the connections with the new connection box that we might have sent you. Okay. Now, in order to ease up that, what we did was when it came to the primos and the simos, we made it such that the electronics is kind of like a swing out unit, whereas the connections are passive and it stays behind on the mounting bracket. So that is the reason that we call it a snap inverter, because you snap out the power stage or the power stack, if you will, which is the actual inverter. And when you get the replacement, you snap the replacement in. Now, that was a significant advantage, and we found that a lot of people did like that because it saves you a ton of effort should it come to warranty replacements or even out of warranty replacements. So we carried that feature through. Because it was a positive feature, but we also did get some flack because despite adequate information, what should I say, instruction, if you will, about not using power tools, people did continue using power tools, and that kind of worked against us because we tried so much, and there's only so much time, so many times we can absorb the cost of damaged inverters due to power tool use. So what we did was we did away with screws. Okay, you still need screws, but not to actually install the device. So here we carry the concept of the mounting bracket, except the wires here don't come on the mounting bracket. They go into the device itself, into the shell of the device. So the mounting bracket concept is here. The power stage concept is here as well. The screws aren't here anymore. So these are only 180-degree half-turn twists. So what that means is if you need to undo the screw, you just take a Torx T25 and give it one half turn in the counterclockwise direction, you've undone the fastener. Okay, so you can pop that little cover off, which you can see in the third picture from the left. That exposes the connection area. This connection area is very similar to the connection area on the primos and the simos, except on the primos and the simos, the wires go behind the unit. In this model of inverter, the wires actually come into the unit in the connection area. Now, in addition to that, we had a Benedict block on the older models, the primos and the simos, and there too we saw a ton of power tool use and a lot of associated damage and a lot of cost for us as well. So what we did was we did away with that concept, if you will, and we came up with these sorts of connectors. So you basically lift the orange tab, you release the catch, and you've got your stripped wire, and you insert the stripped wire and you push the orange tab down, you've got a little blade kind of connector on the inside which bites down into the wire and holds it there. And then it's just what should I say, a slide-in connector. It's got a little tab on the inside, and we've got separate connections or connectors, if you will, for the positive and the negative, and they are keyed differently. So there's no way you'd be able to put the positive connector in the negative slot or the negative connector in the positive slot. In addition to that, we kept all the positives, that is positives from the PV array and the positive coming from the battery on one side of it, on one connector that is, and similarly all the negatives on the other connector. So there's going to be very little scope for you to accidentally short either the battery or the PV array because the polarities got switched. Okay. Oops, sorry. Now, one important feature that you have to keep in mind here is there is no more display on this inverter. Okay, so if you do want to interact with this inverter, there is an infrared sensor right in the middle, and you'll need to hold your finger against that for just a second. What that does is that will activate the Wi-Fi access point on this inverter, just like how we would have activated the Wi-Fi access point on the data manager card in the previous inverter on the master inverter. Now, there is no more data manager card here, and there is no display, except the display and the data manager card have been combined together, and we call that the pilot, and every inverter has a pilot. Okay, so since there is no display anymore, if you need to commission the device, you would activate the access point on the inverter. You would connect to the access point using a smart device, just like you would with the data manager. It could be a smartphone, it could be a tablet, it could be a laptop. And then you can either choose to use the Solar Start app. Again, you don't need to pay for the app. You don't need to sign up for the app. You could just download it and use it without signing in. Or you could use the same web interface as you would for the data manager. We've kept the IP address the same. Okay, so you use your smart device, you activate the access point on the inverter, you connect to the access point using your smart device, and then you bring up either the app or the web page using the IP address, and then it's the same as you would for the data manager. This is kind of what it looks like, and you see the picture here on the right side. You got that symbol for the finger. That's where the infrared sensor is. And like I mentioned earlier, the display and the data manager card have been combined together, and we call that the data communication unit or the pilot, and that's what it looks like in the picture on the top right. Okay. So whatever we could do with the previous models of inverters, all of those features are available with this model of inverter as well, because all of those are standard requirements of any inverter if you want to sell them on the market as a part of the SunSpec protocol. So now we've got the LED display status. There's no more display. So if you want to know what the inverter is doing, you need to be able to interpret what the LEDs mean. And for that, we have a sort of sequence. I mean, I won't get into that now because it's more of an installation issue. Okay. Now you can connect this device to the internet either via a wireless connection or a wired connection, just like you could with the data manager card. And just like the data manager card would basically log data and upload it to your monitoring platform via whatever method of internet, via whatever method of connecting to the internet you choose, the same concept holds here as well, except here it's the pilot that's going to be doing all of that. Now, the platform itself is still SolarWeb. So if you've used Fronius before, it's the same platform, nothing changes there. How you would have visualized any sort of production from a system that utilizes either IG pluses or primos or SIMOs, it's the exact same way that you would see the utilization and the visualization of data from the Gen24 Plus as well. There is no more AB switch on the data manager, like on the previous data manager. Sorry, on the Gen24, like the previous data managers. In addition, you can also have all the other interfaces of, like we had on the data manager. You can use Modbus TCP or you can use Modbus RTU. We've got the API. We've also got the SolarWeb API. You've also got the push service. We've also got the wired shutdown and the digital IOs. The only thing that is missing here is there was a dry contact on the previous model of inverter for rapid shutdown initiation. That dry contact is missing here. And since that dry contact is missing here, we will need to mimic what the dry contact does by the use of an external e-stop or a push stop button if you want to go with string level shutdown. Okay, now in terms of efficient energy management, this is a slightly advanced topic simply because a lot of us do not use it here. Now, for those of us who have been exposed to any sort of smart meter use with either the IG Plus or the primos and the SIMOs, that same concept and how the smart meter works there is carried through into this model of inverter as well. And just like before, how you would use a smart meter to perform either dynamic export control or zero export systems as well, we can do all of that here as well with the smart meter. But do keep in mind that if you should want to use a smart meter, you'd still need to get your own CTs, which go in the AC panel board. Okay, oops, sorry. Now, in addition to that, you can actually kind of game the system, if you will, using the IOs. So these are what we call programmable IOs. Now, just to give you an example, this is more dependent on what you're trying to achieve, because, like, for example, in Europe, hydro companies in Europe are typically not interested in buying energy from you because energy in Europe tends to be way, way more expensive than energy for us in North America. Okay, so electricity is very expensive there comparatively, which is why for them, battery storage actually just is very quickly, what should I say, justified, from the money side of it, whereas for us, it isn't. So for us, if, your ROI on the battery could be several years, for them, it's much shorter than that, simply because their energy price is that much more expensive. Why am I talking about that? Because for a lot of the, the way the market is set up in different countries, for, again, taking Europe as an example, if your battery is already full and it's afternoon and it's bright sun and there is no energy consumption happening at home, you've got to send the energy back to hydro. Except hydro is going to only pay you peanuts. In which case, if you had the ability to program your loads using the IOs, you can actually game the system. In the sense, your battery's full, you don't want to send energy back to hydro, then you can basically have your washer dryer run or your hot water heater or something like that. So that way, you're actually using your own energy instead of selling it, for throwaway prices to hydro. So all of those are already possible. They were also possible with the previous data managers. It's just that you need to be able to have loads which are controllable, which could be interfaced with those programmable IOs, which is where we talk about maximizing self-consumption without selling energy back to hydro. But then, like I mentioned again, this is more geared to different sorts of markets based on what is available in those markets. Okay. Now, the DC to AC oversizing, a lot of you already know what DC to AC oversizing is. I just wanted to throw this in there because oftentimes people try to optimize, if you will. And what we would rather recommend you do is maximize instead of optimize. In the sense, if you've got the roof space, and why not just go to 150%, simply because it's easier, because your PV panels, PV modules per se, are actually passive. There's nothing on them to actually fail. And also the reason why people offer them 30-year warranties, because typically they have the last things to fail on any PV system. And also the price of PV modules typically are on, like a decreasing trend all the time. And I'm not sure how long that'll hold for, but at least it looks to be. So, which is why we suggest that why not invest a little bit more money and throw on more PV modules than throwing on more electronics on the roof in terms of optimizers, if you will, because your optimizer is active electronics, and active electronics have a higher failure rate than passive electronics, and your PV module is passive electronics. Okay. And also we know that, when you do oversize it, there will be seasons of the year when you will tend to clip because it is oversized. But the flip side of that is during conditions of low light or cloudy weather, you could still get potentially the inverter working at capacity simply because you've oversized the PV array by that much.
Yeah, the other thing here to remind people, and I know many of you know, but solar panels are rated in standard test conditions, right? So
Yep.
how they're tested is basically they're put in a dark room that's temperature controlled to 20 degrees Celsius, and then they're exposed to, I think it's 1,000 lumens per square
1,000 watts.
meter,
Yep.
or per 1,000 watts per square meter, and then they check the output. This is really not that common in real life conditions. So
Exactly.
a panel that states it's a 450 watt or a 500 watt panel is in reality, it may produce that in the spring, in a cold spring day or something like
Exactly.
that, right? Or,
Yep.
but on a hot summer day, that 500 watt panel may only produce 450 watt, right? Or even less. And I don't know exactly what it would be on the temperature, but generally the hotter that the solar panels get, the less power they produce.
Exactly. So, and this, like Danny was mentioning, those are standard test conditions, which are basically lab conditions, which, not that they won't happen in real life, they will, but for a very, very limited amount of time, usually when it's very cold and very bright, that's usually like spring or, early fall, if you will. But outside of that, in summer, for example, if it's a flush mount and you've got maybe 2 or 3 inches behind the panel and between the panel and the roof, there's not much air circulation. So which means that the panel now could easily be working at 80 C. And remember, the panel was rated to give you 500 watts at 20 C, but now at 80 C, it won't give you that. So, the simple method to do basically get as much as possible from the roof, especially because you've got roof space, assuming you do, and the cost of panels are always going down, is just oversize it to the max, which is 150%.
Correct. A couple of questions here on the data manager. Is there still an A/B switch on the
No,
Gen24? No.
no,
So
no.
that's not. So that's a no. And then if the alignment of the string is one east and one west, what could be the estimated oversizing rate?
See, the oversizing is not per se dependent on the directions they face, it's the sum together. And so if you've got an east and a west, we would recommend that you put them on separate MPPTs, but together you still have to keep them under the 150%. It's not about 150% at a particular time. It's 150% together.
Cosman was commenting about irradiation in real life can exceed 1,000 watts per square meter. And yes, that is correct.
Yes.
However, over the course of the year, generally it does not. It does not meet that 1,000 watts per square meter in the Canadian climate, and you should definitely look at oversizing your system and not worry about a little bit of loss in the spring and early fall, and really design the system properly for the long term, because solar panels have gotten really, really inexpensive. And it doesn't cost that much to install some additional solar panels and keep your AC, and this is really what it comes down to, especially on a residential system, but also on a commercial. You have existing infrastructure on the AC side that you're working with. Generally, you don't want to go above 9.6 kilowatts on a residential project, right? Because you don't want to upgrade your electrical panel. And then, so that 10 kilowatt inverter could technically be derated to 9.6 kilowatts.
Yes.
And then you can put up to 15 kilowatts of panels on that inverter. So that would make sense, right? What doesn't make sense is to install in like 2 6 kilowatt inverters. You have more upfront costs on inverters. You have to upgrade your electrical panel.
I know, yeah.
Just to put on, like, for what, a little tiny bit of extra production per year. You're talking like 100 kilowatt hours a year of extra production or something like that. It's very, very minimal, and you're not going to get a good payback on that extra multiple thousands of dollars of investment.
Yeah, that's very true. So this is something that you know, you like, if you're doing it for the first time, it might not be so apparent, but you'll quickly learn that, you know, that it's just simpler to go with a 10K derated to 9.6 and oversize. And also the oversize is based on the non-derated nameplate capacity. What I mean by that is I can put 15K's worth of PV array on a 10K inverter and derate that to 5K. Okay, so your derate, you know, the oversize is not based on the after derate value, it's the nameplate value.
It's also really important here that we're trying to design not the most efficient solar project, right? We're trying to design the most economical solar project, right?
Exactly.
So that's something to keep in mind. Yes, you can have a project that is a little bit more efficient, but it's not going to make your customer more money at the end of the day.
Exactly. Were there any questions?
A couple more questions. So will we need a separate switch to activate the rapid shutdown? Are the Quattros and Duos being phased out?
We're not phasing them out, but you will need a separate switch. We are actually coming up with a Duo and a Quattro with higher current capacity, because the current Duos and the Quattros, their channel capacity is limited to 25 amperes. That typically comes down to a short circuit current of just over 10 amperes. So if you've got the higher power panels that you intend to use, you'd be limited to one string per channel, which is why we are coming up with a newer version of it. But you would need to use an external switch to initiate rapid shutdown.
Remind me, are these inverters SunSpec certified?
Yes, they are.
For rapid shutdown, right? So one of the things that a lot of installers like is the rapid shutdown devices from someone like AP Smart. They are they're a dumb unit. It doesn't do much. It just turns off and on. It doesn't do any actual power electronics inside. They have very low failure rates, and they will be installed on every panel. It's really easy to install them, and installers really seem to like using those.
So this is actually compatible with AP Smart for the SunSpec module level shutdown. The transmitter is built into the device already.
Amazing. So you just need to buy those rapid shutdown devices. I think they're like $33 a piece or something like that. It certainly adds a little bit of cost, but
Yep.
with the higher power panels, you're probably looking at 20 or so a project, which kind of is in the similar ballpark range as the rapid shutdown boxes anyways. And it's easy to install them.
Yeah, and also if you did go that route, you could save on the cost of rodent guard and things like that as well.
Correct. That's depends on the jurisdiction.
It depends on jurisdiction, yes.
Correct, yeah. How well does the Gen24 integrate with a third-party warranty, solar equipment, or energy management systems?
How do you mean?
There's a question here. So I guess, Frederick, if you can add some additional context to that, but I guess it's just about my thought would be that it integrates just fine with any third-party monitoring that's out there. But
wait, are
maybe
we talking about third-party monitoring or third-party energy management?
Third-party solar equipment or energy management systems.
See, when it comes to energy management systems, they're typically just looking for a digital high-low, and how you kind of structure what is high-low, inside is based on you. So for example, if you did want to use it, let's assume that you've got a smart house, a smart home with smart appliances, okay? And your smart appliances typically will need to be given some sort of a digital input to get them to work based on the time of the day or how you choose to game the system. For example, in the afternoon, if you've got more than 2 kilowatts being produced and nothing to dump that energy into, then you would basically game the system by saying that you want to turn your washer dryer on. So now that means that we need a digital high-low to tell the washer dryer to turn on. So that interface, like how does that compare with the warranties? That I couldn't per se speak to it, simply because your third-party energy management device needs a high-low. This device can give you a high-low. So we basically stop our business at delivering the high-low based on how we program the pilot here. And what the third-party device does by taking said high-low is up to them. How does a warranty match is kind of sort of a gray area, but usually it's not so much of a warranty condition as such. Does that answer your question?
I assume so. Otherwise, please write in the comment section. James was just commenting and making sure that when you're using the AP Smarts, you don't need the transmitter. And yes, that is correct.
Correct.
It's already integrated in the Gen24.
That is correct.
And I think that's it for questions for time being.
Okay. So we were talking about oversizing, and basically I was trying to justify that, but Danny, you already kind of gave a very good example of where we shouldn't be talking about optimizing. It's more about the economics.
And I want to use this opportunity actually, because it's something that comes up a fair bit, and I've had the opposite as well, where people really get like lose the focus and think, oh, I need to oversize by a certain amount every time. Like I need to oversize 30% because that's how we do it. But it really is important to look at the specific situation you're dealing with. What is the existing infrastructure? There's no downside to install a 9 kilowatt, or like, let's say what is it, a 7.6 you have, right? A 7.6 kilowatt inverter. If you only have 8 kilowatts of panels, right? Because it doesn't really matter. Like you don't need to necessarily go down to a lower power class. You look at what the cost difference is between the different inverters and what it will cost if you need to upgrade or not upgrade existing infrastructure, and then you're looking at that. But don't lose sight. It doesn't really matter if there is 10 or 15% oversizing or 30 or 40%. What you don't want to run into is upgrading existing infrastructure or if there is a big cost difference between two different power class sizes of inverter, which sometimes there is because of going to a larger unit, like a higher powered unit. So how inverters are created is basically they create a unit and then they derate to different power classes, right? That's why you
Exactly.
have the two different sizes that you showed at the beginning. Is you have the, can you go back to that slide quickly, where you have the 3.8 and the 5 and the 6, I think, right? No, 3.8 and the 5, that's one unit. So both of those are technically a 5 kilowatt inverter. The 3.8 is just derated. The
Correct.
same with the 7.7 and the 10. So for Fronius to manufacture those two units is like they're the same, right? It's just a little bit of
Correct.
derating that happens. So generally you start seeing a little bit of a price jump going from a 5 to a 6, from a 6 to a 7.6, but there shouldn't
Correct.
be a crazy amount between the 3.8 and the 5. So just something to keep in mind. That's sometimes where the price jumps happen, and those are the things you need to consider.
Correct. And that's actually very, very important. And a lot of people kind of tend to lose focus there because they get into this part of technically optimizing something. But this is more a game of, a fractional jump in cost versus fractional, change in design.
Correct. So just a reminder on keeping in mind what is really important, and that's the overall system cost and what's best, like what the best design is overall. And there's not
Correct.
a cookie cutter solution always.
Exactly. That's very, very important. That's something that we have to keep in mind. There is no cookie cutter and there is no one size fits all.
Are there any plans to replace the Fronius 15 kilowatt Primo?
We are working on it because it's actually our best-selling model, which is what we've also been very effectively giving feedback to, Fronius International and product design on, because that's something that we really need and want.
Yeah, we've seen the same, obviously, and it's become a real problem because it doesn't have the latest certification, and a lot of places where these units are being sold is requiring the SB certification that Fronius currently doesn't have with the Primos,
Correct.
the old
Now,
Primos. Yeah.
exactly. Now, I did mention that although we are not 1741 SB, despite not having the certification, the inverter actually meets a lot of those requirements. So if there are any special situations where they're more keen on the write-through capabilities and things like that, the inverter meets all of those without the certification itself. So if you need any sort of help there, or if you need for us to speak to, the utility or the engineers there, you could always, call it in and we'll try to help you on that. Simply because we don't yet have a replacement for the 15Ks. Whereas if it's only for write-through and voltage management and other advanced functions like that, which are a part of 1741 SB, these inverters, despite not having, the old Primo 15s, despite not having 1741 SB, will meet all of those requirements. So if you're in those sorts of situations, you could always just call it in and we'll help you with that. I'm not saying that your utility or the authority having jurisdiction will always buy it, but we can definitely try.
Would there be a timeline? Like, are we talking
Oh, you mean for the replacement?
2026? Yes.
See, for the three-phase, there's actually already released. It's called the Verto. So we are trying to get that in.
Yes.
It's the certification on it, but the timeline for the single-phase 15K, I don't have that yet.
You don't have a timeline. Okay. And what did you say the timeline for the three-phase product is?
It's supposed to be 26, but don't quote me on it. It's called the Verto. If you want to look it up, it's already launched in Europe.
Yeah.
Okay. Now, outside of that, this is a dynamic peak manager. Now, the reason I'm bringing this up is oftentimes, especially when people are trying to sell you optimizers and microelectronics and say, oh, you don't need to increase the number of panels, you can throw this piece of electronics behind it, it'll get you more juice from the same piece of, so from the same PV array. And I'm not going to deny that, but what I'll put it in the sense, what I would pitch to you is the failure rate on the electronics that is going to be used to get more juice out of the same panel is much higher than the failure rate of the panel. And also, your panel is very robust and the price on it is always going down, at least for now. So, and if you've got the roof space, you would rather just throw on more panels than throw on a little more, more failure prone electronics. to get more juice out of the same PV array. So which is why we always suggest maximize that. Okay. Now, in addition to that, oftentimes people tend to oversell the idea, saying that, oh, you got a little bit of shading from this, I don't know, some leaf or some tree or adjacent building, and then you lose so much production from the entire panel or the entire string and things like that. So that's not always as cut and dry, and it's also not entirely true. Every inverter manufacturer out there on the market, irrespective of who the manufacturer is and irrespective of whether it's a micro inverter, a string inverter, or a central inverter, they all use one or different forms of maximum power point tracking, or MPPT for short. Okay. Now, our algorithm is proprietary, and it's called the Dynamic Peak Manager, or DPM for short. And we too have that here, and it's pretty efficient. And on the previous primos and the simos, we tend to keep that turned off simply because it tends to interact with whatever other piece of electronics you throw on between the PV panel and the inverter. That could be a rapid shutdown unit, it could be an optimizer. So if the previous dynamic peak manager on the primos and the simos were turned on, it is possible that it could potentially fight that other piece of equipment that you put up there on the roof, because that piece of equipment also has its own algorithm, which is why we would keep it turned off. Now, if you don't have any micro inverters or optimizers that you are using there, and you're only using direct, as in you get the strings directly into the inverter, or using a Fronius rapid shutdown, then we, you might remember that if you've either spoken to Ricky or to me, we would have helped you turn the dynamic peak manager on. Now, if you turn that on under low light conditions, or if you have shading issues, etc., you will get about 3 to 5% more energy if that is turned on versus if it weren't. Okay. Now, that same algorithm has been tweaked even to make it a little better, and now is also always turned on this, the Gen24 inverters here. And the reason I'm mentioning all of that here is to kind of wean you away from using micro inverters or optimizers, simply because their failure rates are greater. And not just that, you can get much better bang for buck merely by oversizing the PV array. Because we already know that the PV array's output, despite what the claim is very much going to change depending on the temperature and the place it is installed and how it is used as well. So instead of throwing on more and more electronics, which could likely fail, not likely, which will definitely fail, because electronics always will fail, it's more a question of when rather than will it. Okay, so if you are able to just oversize the PV array and use the advanced algorithm, you will get the same output, if not better, versus throwing on more and more microelectronics up there on the roof. Okay.
Yeah, it's also important to point out that, for example, optimizers, they also have an efficiency loss. So under ideal light conditions, a string inverter without optimizers will pretty much always outperform an optimized solution, strictly because you have 2 points of energy loss, right? So
exactly,
you have your optimizer that's like 98 point something efficient, and then you have your string inverter that goes with that, which is also, I don't know what it is, but like you're looking at like 97% efficiency-ish. Yeah. So you have 2 points of losses versus 1 point of loss on a string inverter.
Exactly.
Correct.
And in addition to that, you have, go ahead.
And then the other thing is, obviously from a maintenance perspective,
exactly,
you're looking at having 20 optimizers or microinverters on a roof, and you have annual failure rates of a couple of percent. Now, that adds up, and you're going to be fixing a lot of optimizers, especially over a big portfolio, and you'll have unhappy customers.
Exactly. And when it comes to replacing, failed optimizers, you also have to remember it's not just the cost of the optimizer, it's also the cost of the labor, because you can't per se predict how optimizers fail. So if some optimizer in the middle of the PV array fail, then you literally have to tear up the array to get access, merely to get access. There is a cost associated with all of that work. So all of that adds up pretty quick.
Yeah, and some manufacturers do pay for the replacement and your labor. However, if you look at what they pay, I think it's $300 per truck run, plus like $25 per inverter. It's not gonna cover your costs, and then the customer's gonna have to pay out of pocket, or you're gonna have to cover the difference, which again, not going to, either you're not happy or the customer's not happy, and the customer feels like the labor is covered, so you should be
It should,
carrying that cost.
yeah. That's also, I'm glad you brought that up, because oftentimes a lot of end customers who are new to solar don't actually understand how this works, because their understanding of how warranty works would be from FMCG, which is fast moving consumer goods. So it's kind of like your phone or some other piece of electronics that dies. The way the warranty on those devices work will not translate into how the warranty works here on solar. And a lot of people aren't aware of that. And so this also causes a little bit of grief and friction there as well. And in addition to that, you also have to remember that there is a cost to downtime, because that is lost production as well. So that too will add up. So if I've got to replace, I don't know, on a site with 100 optimizers, if 3 fail every year and they failed on 3 different strings, that's like me losing production from 3 different strings, right? And for how long before your installer comes in and takes them out and sticks a new one in that place? So all of those are costs, and they will add up. So this is something that if you're getting into solar, for the first time, or you're new to solar, this is not something that you get to see upfront unless you've been in the industry for some time.
Yeah. The final thing I want to say in caution is there are some proprietary products out there where they use trunk cable and or optimizers that will only work with a certain string inverter, and string inverters that require that specific optimizer. And I would just say that if those companies cease to exist, your
Yeah.
customer has a big problem on their hand, because if there's anything failing, you now have to either have those panels not working anymore and live with that,
Yep.
or you're going to have to go uninstall all the solar panels and then reinstall, take off all the optimizers or microinverters and then replace it with something else. If the same thing were to happen with a string inverter, let's say an example, Power One was a company that was around 8 years ago. They made string inverters, and now you have that inverter and it's failing. Now what you can do is you can have your choice of pretty much any string inverter out there, Fronius or any of the other ones that we carry, for example, and they can just be replaced very easy because string lengths are the same. It's very, very easy to replace it. Yes, you don't have warranty on that product anymore, and the customer will have to pay some money for a new unit. However, you don't have to go on the roof and restring anything or take off any solar panels or anything like that. So from a longevity perspective, it's certainly a much cleaner and solution and a lot more peace of mind.
Exactly. And here too, this is again something that you won't get to know unless you've experienced. Like I'm not saying that you should go through it. It's not exactly a nice experience to go through it. But unfortunately, you've got to remember that inverters are typically warranted for 10 years. So now, if you buy into some newfangled technology because it was really attractive in the way it was packaged and pitched to you, and let's assume the company is barely 2 or 3 years old, we don't know if they're going to be here for the next 7 or 8 years or things like that, which is where the bankable side of it comes in, which is why you always want to go like, there's lots of new manufacturers out there in the market. They might be here today, they might not be here tomorrow. So you've got to basically keep all of those factors in mind as well when you're building a system, because like Danny mentioned, if they're not here tomorrow, what are your options? Who's going to foot the bill? How are you going to hedge for that? So things like that. Okay, so if there aren't any questions, I'm going to take you to the next slide. Okay. So this was basically kind of trying to get you to basically not use more and more electronics, instead just oversize the PV array and enable the advanced algorithm. And if you did do that, then if you did have partial shading conditions and you did not enable the algorithm, or you weren't using this sort of an algorithm, the portion that's hashed in red is the amount of energy under the curve that you would lose. Versus if you did have it, that is how much additional gain. So you remember I told you early on that if you had low light conditions or you had shading issues, then if you were to turn on the algorithm, it'll get you 3 to 5% more energy versus without. And in this model of inverter, the Gen24 is always turned on, so there's no question of you having to go in and do something special to turn it on. Okay. Now, in addition to that, excuse me, if you've ever worked with Fronius, you'll see that all Fronius inverters are always actively cooled. Actively cooled implies there's an actual spinning fan. Now, some manufacturers claim that a fan's failure rate prevents them from using it. Okay, so it could be the case, but then typically if you know how to source your fan, that shouldn't be the case. And also, if you are running on a passively cooled inverter, the standard operating temperature or the ambient operating temperature inside the inverter typically tends to be higher for a passively cooled inverter, which is basically just a massive heatsink with no fan, when compared to that of an actively cooled inverter. And also you have to remember, the cooler you keep your electronics, the better they perform and the longer they last you, which is why we actually have a lot of faith in actively cooled inverters. And also from experience, we know that the fans that we source tend to have very low failure rates. In addition to that, Fronius is very, very committed to reduce, reuse, recycle, and sustainability. So the aluminum used in the entire inverter here is all recycled aluminum. That includes the heatsink that you can see up front. Okay, so these are all different features and benefits of having active cooling, basically with forced ventilation, that is a fan. Okay, now outside of this, given that now there is a big, what should I say, a lot of interest in storage and in basically making yourself immune to power outages from hydro. With that in mind, we have this feature which we call the PV point. Okay, now the PV point does not require batteries. And also, the PV point is only 120 AC, not 240. So it's only line neutral, not line neutral line. And it is only active when hydro is down. So if it is daytime and hydro is down, then you can get 120 AC continuous, okay, the 1.5 kilowatts. And in addition to that, it has an inrush capacity of 2.5 kilowatts for 3 seconds. Okay, so if you do have any sort of loads, emergency loads, or you want to charge your cell phone, mobile phone, whatever, during an outage, then the PV point is your go-to. Now, please keep in mind that the PV point cannot be wired into your AC panel board, your breaker panel. Okay, that's a violation of code. So it will need to be wired into a separate receptacle by itself. And if you need to have protection, you'll need to also throw in a circuit breaker there. Okay, and again, this is only active when hydro is down. The moment hydro comes back, this is inactive, sorry. And so you don't need, again, you do not need batteries for this to work. As long as you've got daylight and hydro is down, this is active. Okay. Now, outside of this, if you have worked with Fronius, you know that if you were to switch out a snap inverter, it's very simple because you don't have to undo and redo your connections. All of that is carried through into this as well. So it's very easy to troubleshoot, just like how we would troubleshoot any prime or SIMO. We've got the same self-help tools. So if you have used Fronius SOS, short for Solar Online Support, all of what you could do for the troubleshooting when it came to the Solar Online Support for the old IG pluses, the primos, and the SIMOs is also still possible here. Okay. In addition to that, we've kept the modular concept going as well. So if you are trained to be an FSP, just like how you would change out printed circuit boards instead of the full inverter on the older inverters, you can do the same here as well. Okay, and since you don't need to replace the full inverter, it's much shorter when it comes to replacing printed circuit boards. And also, just like how you had the old primos and the SIMOs, if you are in requirement of a replacement, then we would send you the power stage, whereas the mounting bracket, etc., the wiring stays there because all of that is passive, and you don't need to undo and redo that. The same concept holds here as well. Okay, now that's as far as the string, inverter side of it goes. But I did tell you that these are hybrid inverters. And one thing that I did, I forgot to tell you early on was the inverter, were you to buy it as a regular string inverter, already has the hardware built into it to make it a hybrid inverter. The only difference here would be the software. Okay, so what you could do is, let's assume that you are now interested in solar, but not exactly that interested in storage. So you could buy the inverter now, get your system built, and maybe 3, 4, 5 years down the line, you think that it makes sense now. Maybe hydro rates have been jacked up that high by that time that now you are kind of, actively investigating storage. Then what you would do is basically buy the battery and pay for a software upgrade to turn the same hardware into a hybrid inverter capable of working with batteries. So for now, the inverter is capable of working only with the BYD HVM batteries. These are high voltage batteries, not low voltage batteries, and they come in those power stack capacities, and you can expand them. And these are DC coupled batteries, not AC coupled. Okay. Now, in terms of how the system would work, is we call this multi-flow technology. So you can charge the battery from the PV array, from hydro, that's from the grid, or if you've got an older, excuse me, snap inverter based system. Let's assume that you've got two Primo 10s now, all right? And you want to throw in a Gen24 10K as well with batteries. Now, previously the Primo 10s, without the Gen24, not the hybrid versions, the regular string inverters, if hydro was down, the inverter is down because those were grid following inverters, no grid, no inverter. Whereas now, given that this is a hybrid inverter, let's assume that with the Gen24, you got a battery stack, hydro is down. So Gen24 makes its own grid because it's a hybrid inverter. Now that you're making your own grid, that grid interface is a good enough grid interface for the previous, I told you about the two 10K primos, the older styles that you had, which means that previously when hydro went down, those two 10Ks would have gone down, but now they won't because the Gen24 is going to be the grid when hydro is down, which means that the PV array feeding the other two 10K inverters can potentially be used to charge the battery here via the Gen24. Okay, so on the AC side, you can couple it that way because, like I told you earlier, I can charge my battery by taking AC power from hydro and converting it into DC and charging the battery. Now, since hydro is down, the AC power to charge the battery can come either from the Gen24's array itself or from the arrays connected to the other two primos and then AC coupled with the Gen24. So you could do that as well. Okay, so these are
That is
different.
if they're net metered, right? Not under a
Correct.
microfit, for example. So just keep that in mind.
Correct.
Like if you
Exactly.
are connected to the grid directly and not to your electrical panel, then this doesn't work.
No, this is only behind the meter, so you have to be sharing the same panel board. It won't work with this thing, with the net metered system. Okay, so these are all different ways you could use this thing, but for now, it is only the BYD HVM. But at the same time, we are working on making it compatible with more than BYD. In addition to that, we are also working on a Fronius branded battery as well. So we call that the Reserva. It's currently being launched in Europe, but we are working on getting that here as well. Do you have any questions on this?
Is there an AC coupling limit when in off-grid mode? That's from James.
Not that I know of, but I can check and come back to you online.
Thank you.
Okay, now if there aren't any questions, I'm going to jump into the next topic, which is retrofits. Now, what I mean by retrofits is, let's assume that you've got a 12-year-old PV system, okay, and typically inverters are warranty for anywhere between 7 to 10 years in our market. And given that it's a 12-year-old system, your inverter is out of the warranty period. Now, if the inverter dies, then you might not have that same model of inverter on the market anymore. And also because if it is out of warranty, you might not be able to get support and spares for that, or your manufacturer might not be present in the market anymore, or maybe you just want to tear down the system and do something else, or you see that the performance of the system is degrading and you attribute that to the inverter's performance, and maybe it's older technology and you want to switch that out. Now, in all of these cases, typically what you would do is, in the interest of keeping the cost down, you would like to utilize as much of the array as is and merely replace the inverter. So this is basically what a retrofit is. You're trying to switch out the inverter without too much other change. Okay, now that isn't as simple, and it also isn't as cut and dry, because you have to remember that in the course of these 12 years, that's how old your system is, as an example, the technology of the inverters out in the market have changed. And because they have changed, the way you would use an inverter now, which is a transformer-less inverter, pretty much every inverter on the market now is transformer-less, is it comes with its own, what should I say, specific requirements,
Challenges.
which might not have been applicable to the old inverter that you're pulling out of the system. Okay, so what that means is if I'm pulling an older transformer-based inverter out of the system, that transformer-based inverter has certain advantages, okay, which may not be available in the current technology of inverters available in the market, irrespective of who makes the inverter. Okay, so what I mean by that is you've got the PV array. The PV array is exposed to the weather. Okay, you got the cabling that goes with the PV array, you got your junction boxes, your pass-throughs, all of the other accessories, etc. Now, all of this is exposed to the weather because all of this would typically be on the roof. And over the course of 12 years, it's been given a nice beating, if you will, in terms of the integrity of the system. Now, all of those, what should I say, behaviors, phenomena, aging, etc., will change the way the system behaves. And the biggest change here is the degradation of the insulation. You have to remember that your entire PV system is DC and it is live when light falls on it. And so the insulation on the live components of that system, they need to be top notch because it's either 600 DC or 1000 DC, and DC is unforgiving when it comes to shocks. So safety and, in terms of making sure that the system is not hazardous is very, very important. Now, when it comes to inverter technology, that degradation of insulation was not as big a deal for transformer-based inverters, because the transformer within the machine provided you an inherent degree of safety and protection for the device, that is, okay? Now, unfortunately, that also comes with cost, because transformers are very expensive because it's material, it's copper. In addition, they tend to be very unwieldy because of the added weight due to said transformers, and also they tend to be a little less efficient than transformer-less inverters. Okay, but the biggest advantage was it was immune pretty much to the aging and the degradation of the insulation. That is not so when it comes to transformer-less inverters. So now if I'm going to pull out a transformer-based inverter and stick a transformer-less inverter in there, there are certain checks and balances you have to do if you don't want to lose an inverter, okay? So those are what we call considerations, right? So in addition to that, there's a few other considerations as well. So you have to remember that back in the day, hydro would not let you go beyond 600 DC, or ESA would not let you go beyond 600 volts on the DC side. That isn't the case anymore. So now the inverters on the market are available, which would potentially work at 1000 volts DC, but you have to make sure that if you were to connect this to a 600 volt inverter, 600 volt PV array, that the inverter's performance is not compromised, because I can't get the same amount of power out of the array at 600 as at 1000 without changing the amount of current. And I did tell you earlier on that there is a current limitation on the device. And also your device comes with its own limitations, and your device might not function as well at 600 were it to be designed to work exclusively with 1000 volt PV arrays. So that is something you have to keep in mind. So
that's more on the commercial side of things. On the resi, it's not really a topic,
exactly.
right?
No, on resi, it's not a topic, but on commercial, it is. So this is because, if you take the old FIT contracts, they're all almost exclusively 600 volts DC. So if I've got a 200 kilowatt array, 600 volts DC, and I'm trying to throw SIMOs on it, you have to make sure that the SIMO that you're using is capable of working at 600, correct, as well as it would if it were to be strung up with a 1000 volt PV array. Okay, so things like that. The second thing is your AC phase, components. So you want to make sure that the model of inverter that you have in mind is capable of working with whatever phase configuration that you choose. Then the next thing is the rated power of the unit. You have to remember that the inverter that you're pulling out and the inverter that you're putting in might not be of the same AC power capacity. If that were to be the case, then what would you need to do? Would you need to get it derated? Would you need to get a letter from the manufacturer because the ESA won't approve it, things like that. And then you've got the inverter technology about grounding. This is basically the transformer transformer-based versus transformer-less. So a transformer-based inverter will have one pole of the PV array tied to ground inside the inverter. So if you did have a failure of insulation due to degradation, it isn't a big problem because you're already bounded to ground inside the inverter. Transformer-less inverters are floating inverters. You can have zero contact to ground on the DC side. So neither the positive nor the negative can ever come in contact with ground. If it did, you will lose the inverter. So that is what we call a ground fault. And the degradation of insulation contributes to exactly that, which is why you have to check for leaks to ground on the DC side of the PV array, preferably under wet conditions, because merely having failed insulation didn't mean you're going to touch, have a leak to ground, because air does not conduct electricity. So you need to be well aware and adept at making sure that you perform an insulation test on the PV array using a megger or a mega ohm meter to make sure that there are no leaks to ground before you hook up an inverter to an older PV array. Okay, after that, there's another thing you have to keep in mind, the DC to AC ratio. Because back in the day during the FIT contracts, many people sized the DC to AC ratio to almost 2. So I've seen systems with 1.75 and 2. Your newer manufacturers, the newer inverters made available from manufacturers now might not allow for that. So that is also something you have to keep in mind. In addition to that, rapid shutdown. Back in the day, you did not read rapid shutdown. So if the authority having jurisdiction is willing to grandfather you into the new system with the new inverter, that's fine. If not, you might have to take that into consideration. Outside of this, you have the balance of system components. So if you've got any switches, fuses, protection equipment, all of those will degrade. So you have to make sure that they are actually functioning like they should be before you decide to trust them. Okay. Outside of this, monitoring. Now, a lot of people assume monitoring is fancy bells and whistles. That's how it appears, but it isn't. You have to remember that the only time anybody actually notices electricity is when it isn't there. What I mean by that is, if your system has failed, the only time you actually get to know if you are paying attention is when you don't get your check from hydro the next month. Okay, this is where the monitoring is very important, because now you're working with a very old system, 12-year-old PV array, which is failure prone simply because it is aged. Okay, so now it is very important to make sure that you are able to keep an eye on the system, because your monitoring is actually not fancy bells and whistles. It is a live health monitor and log for your system. So it tells you in real time, all the time, what's going on with your system. And it is up to you to be able to make sense of what's going on with the monitoring, to use it as a sort of preventive maintenance guide, if you will, because things just don't happen overnight. Aging on the PV array is a gradual phenomenon, and as it ages, there are what should I say, tells, if you will. And if you know how to read those tells, you will know how your system is going to fail, and through that, you can actually do preventative maintenance on your system. So that is the actual advantage in having monitoring. So anytime you're doing a retrofit, we always recommend that you get monitoring, even if the older system did not have monitoring, simply because the older system, by virtue of having the transformer in the inverter, was immune to certain forms of failure, which the newer inverters are not. So it is in our best interest to have monitoring. Outside of this, you have other authority having jurisdiction specific requirements, and that again, there could be many different requirements that they have. You always want to make sure that whatever model of inverter you choose is able to meet those requirements, especially if the authority having jurisdiction or the ESA decides that they will not grandfather the system in. Okay, what I'm trying to get at is, if I were to be working on an old fit system, okay, and they are going to tell you that whatever code applied back then is all that you need to comply with, then you're free to choose anything you want. But if now they come back and say that you need to comply with this new code, then that is going to place a limit on your choice of inverters. So things like that have to be kept in mind. Now, these are things that typically you might not be aware of if you're doing your retrofit for the first time, but if you've done a few by now, you'd have already gone through all of this.
Yeah, and most of this stuff is quite easy to address. Even something like DC to AC ratio. I think discussions can be had with manufacturers like Fronius on how to best address that, either through getting an authorization to oversize to 2-to-1, or
Correct.
by derating inverters
Exactly.
so that they're able to handle the additional oversizing. So all that stuff can be addressed. It's actually, most of it is pretty standard, but I think it's important that we point them out, and it's definitely like things to check before installing a new inverter.
Exactly. Well, that's pretty much all I have planned for today. So if you guys have any questions.
Awesome. There was one more question from Tony, and that is, do you have any recommendations for a remote modem to get internet access in rural systems, for example? I think Tony is in Ontario.
I know that some installers, what they do is they use what are referred to as bullet modems. I believe Microheart makes them, but you will need to have your own source of AC supply for them.
Perfect. There any other questions? I think we answered a lot. So if there are no other questions, then we're gonna. Oh, there, Tony has another one. Will a string with high current, which is not recommended, obviously, be derated to usable current by the inverter, or could it also cause damage like the overvoltage does?
So that depends on the short circuit capacity. Okay, so that's the reason I told you that, for example, if you were to take the Primo the Gen24 7.7 or the 10K, the usable current per MPPT is 22 amperes. Okay, so you can go over the 22 amperes, but the inverter will basically saturate, which is basically flatline. Okay, but your short circuit current should not go over 41.25 on MPP tracker 1 and 39 on MPP tracker 2. So it's the open circuit voltage on the voltage side and the short circuit current on the current side.
So you can't put on 10 strings onto 1 MPPT is basically what this says, right? Because you will cause damage at that point.
Exactly. So like, let's assume that you're using solar shingles. That seems to be the flavor of the season. Okay, so it's not so much how many shingles you can put, it's more about when you string them all together, is your open circuit voltage always going to be under 600 at the lowest of temperatures the site is expected to face? And also, is the short circuit current always going to be under 41.25 on MPP tracker 1 for this particular configuration? That's how you would see it.
Perfect. Awesome. Oh, there, John is asking, is it possible to receive the recording for future reference? Yes, John. All our webinars and podcasts that we do are on our YouTube channel. So just check back in maybe towards the end of the week. Just go YouTube, type in Frank and Solar Americas, follow our YouTube channel, and you'll get all the updates and latest webinars and podcasts that we are doing. Yeah, I think that's just about it. That actually also is a good reminder to follow us on our YouTube channel. And we do a lot of these webinars, so we've been getting more and more people to attend it, so that's great. And oh, there's one more question from Travis. Are there any plans for a Class 1 Div 2 ratings for industrial applications?
As it stands, I don't think so, but I can check and come back to you.
Okay, awesome. Well, thank you very much for attending. Thank you, Harsha, for presenting, and we'll do this again soon.
Thanks, Danny, and thank you all for
Cheers.
attending, and thanks for having us.
Thank you. Bye-bye.
Thank you. Bye-bye.